Okay, fine. So in today's session, I am going to explain you about SDLC, Software Test Development Lifecycle. What is Software Development Lifecycle, and what are the different phases are there in SDLC, and why? I mean, who is responsible for each phase? So that we will be discussing today. Okay. So Raj and Arfin, if you have any questions, please let me know so that we can start with this today's session.
Okay.
Any queries before starting the session?
No, it's fine.
Okay,
No.
fine. Thank you. So first we will discuss what is SDLC and what are the different phases are there. SDLC is nothing but software development lifecycle. So if you go to any real-time company or real-time development, so what will happen? That we'll be seeing stage by stage. Assume that there is a bank and they came for development. So they need a software actually. So they came to a development company, software development company. They requested to develop a software. Now what will happen? How this software company will approach the bank for demanding requirements. So how the product will be delivered. All these things we will be discussing now. Because you should have some knowledge on this, then only you can understand what exactly will happen in the real time. So that was the reason I am explaining this here now. Okay, what are the different pages are there in software development lifecycle? These are the different pages like requirements phase, design phase, coding and unit testing phase, testing phase, implementation, and maintenance phase. So these are the different pages are there at present. I mean in SDLC. So what will happen in each phase? Who is responsible for that? The first page is requirements phase. The responsible person for this particular page is business analyst. So he will go to whenever some company comes to software development company, if they request for software, they will some experts who knows that particular domain. Suppose if it is a banking domain company who came for software, then they will send the experts in that particular domain. So they will go to that bank and they will collect all the requirements from the bank. So by talking with different people, different levels of people, maybe if it is related to core banking, they will go to the banking section and directly they will talk to the employees there, and they will collect the information from them, each and every requirement, and they will document it. That will be called as SRS document, System Requirement Specification or Software Requirement Specification document, which contains all the information about the software. So without this, no one can develop the application. Even developer, if you ask developer to develop the application, without requirements he cannot do it. So that was the reason this business analyst will go to that particular bank or insurance company or a school who needs the software. They will go to that particular location. They will talk to the each and every person in the detailed manner, and they will collect all the requirements and then they will document it. So for this particular phase, that is the output. That SRS document is the output for requirements phase. Okay, then what will happen? Once the requirements are done or freeze, these requirements are the input for the next phase, and the next phase is design phase. Is it clear about requirement space? What is requirement space now?
Yes.
Raj? Okay. So the next page is design phase. In design phase, the system architect will be the responsible person. So what he does is he will take the SRS document and he will prepare two levels of design. One is high level design and another one is low level design. So what is high level design means? List of modules, and okay, here high level design means this architect will give the high level idea to the remaining people. So whoever are there in the next pages, they will give a high level idea. So what are the different modules are there? He will just try to identify the different modules by seeing the requirements. For example, again we'll take the banking application. So take HDFC Bank. So the HDFC Bank came to software development company, they requested for a software, and from our side our BA went to HDFC Bank and they collected all the requirements and they documented it. And now we are calling it as a SRS document. Then this SRS document went to the next page called low level, design page. Their system architect will see all the requirements one by one and he will come up with the modules. So which features comes under which part? Suppose if you take the direct HDFC Bank online account, so there you can see different modules like savings account, RD, recurring deposit, and credit card account. So these are the different modules. Modules are nothing but different parts. So it contains different functionalities again, different features again, and also funds transfer is the other module. So if you have some amount in savings account, then only you can transfer the amount to some other bank. So that is the relationship between funds transfer and the savings. So both are different modules, but both will be combined together. So that information, high level information, what module should be there, that information first he will identify. And what is the relationship between among those modules, that also he will identify here. So what is the relationship between the module 1 and module 2, like savings bank account and funds transfer account? In this case, if we have some amount deposited in the savings bank account, then only you can do the funds transfer. That is the relationship. And sometimes some dependencies also will be there. Suppose A module exists, then B also should exist. So that kind of dependencies are there or not. If it is there, even he will define those things also here. And the next thing is database tables identified along with the key elements. Database for every application, whatever the application it is, it doesn't matter whether it's a web-based application or Windows-based application, it doesn't matter. So to store the data, whatever we are inputting from here, from the front end, that should be stored somewhere. So for that, database is required. Normally in database, all the data will be stored in the tabular format, like in different tables. So how many tables we require? For savings account, maybe we need one table. For keeping all the customer information, we need one table. So like this, we need different tables. So how many tables we require, that also he will identify here in the high level design. And overall architecture diagrams along with technology details. Okay, now we know what kind of application it is. It's a banking application, and we know how many modules should be there now, like savings account, credit card, funds transfer, a recurring deposit, etc., etc. So that information also there, and we know the relationship between all the modules, and we know what is the database we are going to use and how many tables are there. Even that information we know now. Now the last thing what he will be doing here is, as part of high level design, he will design or he will give the complete architecture diagram where the flow should start and where the flow should end. So that information also he will draw a diagram and he will give it to the next pages like development page, etc. And also he will identify which technology we have to use to develop the application. So for example, in this case it's a banking application. So which application we have to use? Say for example, whether we have to use Java or whether we have to use .NET or C or C++. Which technology we have to use to develop this? Even that information he will be identifying here. Without that we cannot proceed. Once the high level design is ready, then we will be moving it to the low level design. Raj and Arvind, here maybe first few sessions you have to listen the theory part, because it is very important to understand what will happen in the real time and where exactly our testing comes. Everything I'll be explaining here. Later, maybe after 3-4 sessions, I'll be explaining you about test case writing. So from there onwards, you will be having some assignments. Even you have to practice. Even test case writing is very important. But first few sessions, it's a theory session. Okay. Fine. So we are discussing about low level design. Once the high level design is ready, then the system architect will do the low level design. So here what he will be doing is he will identify the logic of each and every module. So what is the logic in the savings account module? Logic is nothing but functionality, what functionality it should contain, that particular module contains. So that information he will be defining here as part of low level design. So if you take the savings account, what is the functionality there? So if you deposit some amount into the savings bank account, what should happen? It should calculate the interest, maybe 4%, 5%, whatever it is, for a particular period of time. So whether that is the logic there. And what is the logic of our functionality of funds transfer? If the amount is available in the savings account, funds transfer module will be transferring that amount. What is the purpose of our functionality of credit card? So they will give some amount as a credit, we can use it, and later within 50 days or 60 days we have to pay it back. So these are the different functionalities. And if you don't pay within 50 days, again they will charge you more amount, more interest. So that's how it works. That is about the functionality. So that functional logic they will be identifying here, and also they will write the pseudocode. Pseudocode is nothing but a simple English statement which will give you the information about that particular logic or functionality. Normally this pseudocode will be useful whenever the development starts. So developers will be developing that data, so they will take some information, and by seeing this logic or pseudocode, they will try to write the code. They will directly convert this pseudocode to the C++ language code or Java code or .NET code, whatever it is. Depends on the language we have chosen to develop the application. And another thing what we are going to do here is database tables with all elements including their type and size. So here in high level design what we have done, we have identified the tables, but here what we should do, we have to identify each and every element. For example, one table contains all the customer information. So what elements or what columns that particular table should contain, like customer name, customer address, age, sex, and different things which are related to that particular person, maybe account number. So every detail should be there. So what are the different columns or elements should be there in that particular table with the type and size. Type is nothing but, for example, if you take customer name, what is the type? It's a string. It's not a numeric, it's not a number, it's a string. So that type also they will be defining here. And size, how many characters we have to enter, how many characters user can enter in that particular field, even that details they will be defining here. And then along with that they will be defining the interface details, all interface details. Interface is nothing but whatever is visible to us. So if you take any page, so this is the interface. We are not talking about the functionality. So Flipkart.com, Flipkart logo placement, and these text boxes, this area, the complete information whatever we are seeing here, this is called information, interface. Graphical, normally we will be calling it as a graphical user interface. So where user interacts, we don't know about the logic, and as a tester we don't concentrate on the logic, we just see it from the front end and we'll just test the application. Sorry, we will concentrate on the logic, but we don't concentrate on the code, whatever the developer written. We'll be just inputting some data from the front end and we'll see how it is working. So that is about this type and size and interface details. So here how the logo should be placed, what color the page should contain, where the all the fields should be placed, and what about the alignment, what kind of labels we have to use. So all these details we will be defining as part of interface details. And then complete input and output for each and every module. So what input we have to give and what output we have to get it from the application, that details we will be defining here. So what, maybe if it is a savings account, depositing some amount is the input and withdrawing the amount is the output. This is very simple example. It depends on the application, it will be vary. So if it is some other application, maybe we will be giving some other input. So depends on the application, they will be defining for each and every module what is the input and what is the output. And the next one is error message listings. So what is error message listings? Whenever you, so for example, you have a login page available. So if you enter wrong user ID and wrong password, it should not allow you to log into the application. It should display an error message saying that, okay, so this is the problem, you entered wrong user ID and wrong password. Instead of that, if it sits silent, that means if it is not, if it doesn't display any message as an error message or any information, then user will not come to know what is the exact problem. So that was the reason it should populate some error messages or information messages on the top of the screen or wherever it is, wherever user will see normally. So that's how, I mean, that was the reason even system architect will be defining all the error messages whatever is required for that particular application. So that is about design phase. So these are the two levels, and yeah, for this design phase, high level design document and low level design documents are the outputs. Is it clear? Raj and asking?
Yeah, you're saying the high level and low level designs are output or input?
For this design phase, these two will be the output.
Okay.
In the requirement space, the output was SRS document, and which will be the input for design phase. In the design phase, the output will be high level design document and low level design document.
Okay.
Is it clear, or any queries or any questions you can ask?
No, for design phase, the input is SRS and output is these high and low level design.
Yes, documents.
Okay.
Yeah. Okay. The next phase is coding phase. So the responsible for this particular page is developer. So developer will see the code and he will try to, developer will see the documents which comes as a input to this particular page. So for this coding page, what are the inputs? Requirement document, that is SRS document, high level design document and low level design document. So these are all the inputs for this coding page. So the responsible person is developer here. So he will be writing the code by understanding the requirements. So in SRS document, each and every requirement will be available. So he will try to understand what exactly customer needs. Then based on that, he will try to write the code. And also while writing the code, he will see the high level design documents and low level design documents as well, because it contains remaining information like where exactly, what module should be there, and what is the relation, and what is the database we are using, and what is the technology we are going to use. So everything this architect has given. Only thing is, whatever the details this architect has given, this developer has to develop that as a code, or he has to turn that as a code. So once the development is done, so he will be using different languages, depends on the company, depends on the domain they are working. They will be choosing a particular language like C, C++ or Java, .NET, whatever it is. He will be developing the application. So at the end of this particular page, what will be the output? Source code. Source code is nothing but whatever the script or code the developer has written, that is called source code. executable file. If you double click on something, some icon, one application will be opened. That is called executables. And databases, what database we have used, the database. So these are all the outputs for this particular page. Basically, at the end of this particular page, we will be having a complete application where user can interact easily and he can do his operations. So that kind of application will be ready after this particular page. So here nothing other than that, converting into the code, nothing will happen. And once the coding is done, then the testing phase will start. So for this testing phase, what are the different inputs we have? SRS document, low level design, high level design, and the application. So whatever the pages are there in the above for this particular testing phase, whatever the documents they have generated in each phase, all will be the input for this testing phase. This is the place, or this is the phase where we will be entering as a tester. So in testing phase, what we will be doing is, as a tester, we will be verifying whether the application is developed as per the client requirements or not. Client requirements means, okay, I need this logo here, I need one login page, and after logging into the application, I want to see these many colors and with these particular fields. So like this, client might have given some requirements. So as per that requirements, whether our application is developed or not, our developer developed the application or not, that as a tester we have to verify. Are there any mismatches between the actual requirements and the expected requirements? Then we have to raise it as a defect. And as part of this testing, we will be doing different testing type. We'll be using different testing types like GUI testing, performance testing, security testing, configuration testing, etc., etc. So these are the different phases, different types of testing what we will be doing as part of this particular phase. About these types, I will be discussing in the coming sessions. We have a separate session only for these testing types. There we will be discussing what is performance testing, what is GUI testing, and what is configuration testing. So we'll take one by one and we'll discuss about that more. So here I'm not concentrating much on that because we'll be seeing the SDLC now. And input test data and get the results. So along with testing, so what data we have to use for testing, even that they will be gathering here. Sometimes we may have to work on confidential information like credit card numbers, SSN numbers, etc. So that time, what from where we have to get the data. So if the accurate data or current data is not available, so to whom to contact for dummy data? Normally developers will be giving some dummy data to test the application. Sometimes if it is going to production means real time, then we will have to test with real time data also. So how it is working and how the data is coming back from the another end, that we have to see. This comes under as part of end-to-end testing. Anyway, we will be discussing about these testing types in the coming session. Okay, that is about testing phase. Any questions here in coding phase and testing phase?
Yes, the coding and unit testing phase, the developer is developing the program using the programming language. So my understanding is using the programming language should be determined at the very beginning, when there is a high-level design. Is it true, or it's up to the developer to use any programming language he wants to use?
Yeah, that's true. Whatever your understanding is correct. Actually, in the high-level design page itself, they will be defining the technology. So
okay.
what technology
the
they have to use?
Not the programming language. Okay.
Technology is nothing but, I mean, as part of that, what database we have to use, what language we have to use, what hardware, softwares we have to, other software, supporting softwares we have to use. Everything they will be defining in the high-level design page itself. So here, developers will not concentrate on what they have to use. So actually based on the technology defined, the team will be recruited accordingly. If they define Java, only Java developers will be recruited. If they define in the .NET as a language, .NET developers will be recruited here. So developers will not decide what language they have to use. It will be decided by the system architect in the second page itself.
Okay, perfect.
Yeah. I mean, is it clear about coding and testing pages?
Yep.
Okay. And the next page is implementation page. So in this page, whatever the code developer has written, that will be installed in the client location. So after doing all the testing and everything is done, if testers feels that everything is working fine, then that will be deployed or installed in the client place. That is called implementation. So once the implementation will be once the implementation is over, then the next phase is will be started. That is called maintenance phase. So in maintenance phase, normally three things can happen. Maintenance is nothing but after deploying the application or after installing the application in the client place, what will happen or what are the things are going to happen, that is called maintenance. So whatever the way after buying a fridge or car, how we'll be having a warranty period, in the same way here also some warranty period or maintenance period will be there. So in that particular phase, what will happen, here I have explained. So normally three things can happen. One is bug fixing. Bug fixing is nothing but, so while using the application, even client might be finding some defects. So because we might have missed some defects from the application while testing, so client found those defects. Because it's missed from our side, that was the reason our development team will be fixing that defect for free. Normally sometimes we may have to pay some amount also because of not testing properly, but most of the times no one can test the application 100% because we know some functionality, but customer knows everything about that particular domain. If it is a banking application, he knows in and out. So that was the reason he can work to prepare the application properly. But as a tester, we will be having a limited knowledge. Maybe if you try to understand, maybe 90% you can understand, 10% you will be missing somewhere. So maybe from that 10%, the bugs will be coming. So that was the reason. If any bugs found by the client will be fixed in the minimum in the next period of time. So for that, normally companies will charge any additional amount, and then upgrade. Upgrade is nothing but the client system or client software will be upgraded to the newer versions. Say at present we have Gmail version 1 is available. After some time maybe Gmail version 2. So like that, maybe with some enhancements they will be giving a new version. So for each and every version they will be rectifying the old problems and they will try to add the new features to it. So this is called upgradation. And the last one is enhancement. So enhancement means, for example, after using the application or software for 1 or 2 years, client may be come up with some other new ideas. So he feels that if he has some other features in the application, then his task will be easier. So immediately client will come back to the development team or development company and he will ask, okay, I need these many features, additional features along with the existing features. So what this development company will do, they will analyze the requirements and they will try to come up with the following numbers, like how much time it will take for development, how critical it is, and what is the impact on the current application. If we add some new features, what should happen to the existing system, whether it should fail or whether it is impacting, or what about the design, do we need to develop the application once again from the scratch. So all these things he will be analyzing. Based on that he will give or they will give their output. And also for these enhancements our development companies will be charging the amount, additional amount, because it's a separate new feature. So additional features. That was the reason we will be charging based on the analysis what we are going to do. So that comes on, these are the three things we will be doing as part of maintenance phase. Any questions here?
Question. The implementation and maintenance phase is also the part of duties the QA testers, or it's somebody else's duty, somebody else does these things?
Implementation will be done by someone else, but
Okay.
in the maintenance phase, bug fixing and enhancements, after doing the enhancements, even testers have to involve, because it's a new development and bug fixing. So whatever the bug is fixed, that should be retested. So your testers involvement will be there.
Okay.
Okay, but implementation phase, the testers will not involve.
Okay.
Yeah. So these are the different pages are there in the software development life cycle. Now we will see different software development life cycle models. So what are the different life cycle models? We will see. The first one is, here I am explaining about some 3 or 4 waterfall SDLC models. So one is waterfall, another one is V model, and third one is evolutionary prototyping model, and the fourth one is agile model. So instead of spiral, I am explaining agile because it's very popular and very important even for interview purpose. So that was the reason I replaced the spiral with agile. So we'll see one by one. So first I'll discuss about waterfall model. Okay, before starting this waterfall model, any questions are there in the SDLC, software development life cycle?
So far so good.
Okay. And the next page is waterfall model. So waterfall model means whatever the pages we have seen, like requirements, analysis, design, implementation, testing, operation, whatever the maintenance, whatever the pages we have seen in the top as part of SDLC, all those pages comes one after another. For example, the first page is completed, then only the next page will start. Like once the requirements gathering is done, then only functional testing will start, design will start. Once the design is done, then only coding will start. Once the coding is done, then only testing will start. So like this, even we have resources available, they will not involve in all these processes. So whenever the first page is completed and everyone feels this is complete, then only the next page will start. Once that is done, then only other page. So like this, one after one page will come. Whatever the way water will fall from the top to bottom, in the same way here these pages will be defined. So here you can see there is nothing difficult to understand this model. All the pages are coming one after another. Now what is the advantage and what is the disadvantage with this particular model or waterfall model? Waterfall model, along with the main advantage with the waterfall model is, here nothing difficult to understand, anyone can implement this, any company easily they can implement this. So that is the advantage. Even you don't have much knowledge on the particular domain, you can directly do it. So implementation is very easy. That was the reason till 70s 80s everyone was using this software waterfall model itself as a software development lifecycle model. Even still some of the companies who doesn't know about the other models, they are using the same model. And the main disadvantage with this particular model is, it's a till the end of the testing, client will not see the application. So I'm developing application for a bank, so they have given some time like 12 months time for me to develop the application. So developers took some, okay, business analysts took some time for requirements gathering, then design phase started, design people took some time, and then coding started, coding will be done, then testers will be involved. Once the testing is done, then only client will see the application. And after development, after developing everything, if client says whatever you have developed is wrong, then what we have to do? We have to develop everything from the scratch. So it is very difficult for a company if client is like that. So again, whatever the amount we have spent and whatever the time we have spent, that will be wasted. So by seeing all these disadvantages, they came up with the other models. So because of that only other models came. And the basic disadvantage is that. And also testers will be involving only after coding phase. So if even if they are recruited, they will not involve from the very scratch, like analysis phase onwards. But in some companies, I mean, even testers will be recruited only after development is done, because otherwise, if simply they have to pay the amount to the testers without working. So that was the reason they will be recruiting the testers once the development is done. By the time they will be recruiting all the people, all the employees for that particular day. So that is another disadvantage. If testers involves from the scratch, like from the analysis phase, they can find more defects and they can understand the domain properly and they can find more defects. But that opportunity will not be there in the waterfall model. Is it clear about waterfall model?
Yes.
Okay. Is it Raj or Arfin?
Arfin.
Okay. What about Raj? Do you have any questions till now?
No, I got it so far.
Okay, fine. And the next SDLC model is V model. Okay. So what is the process of V model? Whatever the pages we have seen, okay, the main advantage with this V model is validation and verification will happen. Sorry, verification and validation will happen simultaneously. That was the reason we will be calling it as a V model, is nothing but verification and validation model. So in one page or one side, you can see all the development pages like requirements gathering, analysis, design, coding, etc., etc. And other side of this particular development, we will be doing the testing activities. Testers will be involving right from the scratch. So for requirements gathering, they will be doing acceptance test cases, or they will be writing acceptance test cases. In the analysis phase, they will be writing the system test cases. Architecture design phase, integration test cases. Component design, unit test cases. Like this, for each and every page which are available as part of development, for each and every development phase, there is a testing activity also associated with it. Even testers will not sit idle. So whenever the development starts, from immediately from there onwards, they will be working on the application, so that they can understand the domain properly and they can easily test the application and they can give the quality product. As many of the bugs they will be identifying here itself. So that is about V model. In the waterfall model, that is not the case. Testers will involve only after coding. But here in this particular case, testers will be involving right from the scratch. That we have to remember. And advantage with this model is testers are involving from the scratch, and they're able to understand everything properly and they can test the application properly. And what about disadvantages? So what are the different disadvantages are there with this particular application or particular model?
Too expensive.
Yeah, too expensive. Testers should be involved from the right from the scratch. And again, another disadvantage is even client cannot see the application till the testing is completely done. So these are the problems. Even the testers are involving right from the scratch. Developer, as a user, he is not seeing the application. Again, same problem occurs. After developing the application, if client sees and he says that application is not developed properly and this is what I am expecting, this is not what I am expecting, something like that, if you talk something, so whatever the efforts we have put till that time, that will be wasted. So by seeing the disadvantages from the above models, they came up with the next model called evolutionary prototyping model. So about evolutionary prototyping model and agile model, we will be discussing in tomorrow's session. And yeah, this Scrum is very important. This agile model is very important in the real time. At present, all the companies are trying to use this agile model. And to understand this, you should know some technical terms. Anyway, I'll be explaining you about all these technical terms. Even I have documented all these things here so that you can understand easily. Okay, any questions?
No, thank you.
Yeah, so I'll be sending you these documents, and could you please give me your mail ID so that I can send you these documents to your mail IDs. Just ping here.
Aditya, send it to me. I'll forward it to them.
Sure, I'll do that. Could you please send me your test mail so that I can forward it to you?
You have my link, right? I'll send you the link.
Oh, okay. I'll do it. Yeah. So that's all from my side for today. If you have any questions, you can ask me. Otherwise, we'll meet tomorrow. Raj or Arfi? Any questions?
No,
Okay.
it was very self-explanatory.
Okay. Yeah.
Thank you.
Thank you very much.